All right, let's make sure, please, that your name is at the top with a -2 after it. Let's have you hand those up and over now. And please have your homeworks from the other day out on your desk. Now, someone handed too much. Now, have your homeworks out on your desk from the other day. Here are the answers to those questions. Are there any of them that we need to go through and see? Make sure your name is at the top with a -2 after that. Here's your homeworks from the other day. Is there any of these that we need to see or have questions on? Take a look at what's there. Yeah.
Would you not plus or minus for the square root one?
If it's solving, yes, because remember, if it's x squared equals 25, then it's plus or minus. If it's within an equation, if you put the square root in, it's plus or minus. If not, it's whatever the sign on the radical initially is. That's the difference between a principal root and roots that we find while solving. So if it's just straight up, what's the square root of 16? That would be 4. If it's x squared equals 16, that would be plus or minus 4. Were we good on these? Do we have questions? None at all? Yes.
Like for that, how would you simplify it? Like, if you have like a smaller exponent and like whatever the radical is, like if it's cubed.
Like in this one here,
Yeah.
you leave whatever's left underneath it. You can leave an x squared under a cube root.
Yeah.
But you wouldn't leave like x to the 4th underneath the cube root because 3 goes into 4 once, so we pull that out. Okay? Yeah. 12, hang on, let me go and bounce over. 12, which is this one here. So if I did this, I'd say this is the cube root of, now what perfect cube goes into 32? 8 times 4 times, now a cubed, I break this up into a to the 3rd times a squared. Because that gets me the a to the 5th that I need. And what's the cube root of 8? What's the cube root of a to the 3rd? So that's a 2a, and then the cube root of, in the radicand, I still have 4a squared. Those are perfect squares. Does that matter? No. Why? It's a cube root. Questions on any of the others? Yeah.
How did you do 16?
Now, this one came up. I got a message last night while I was at home about it. So I started doing it out. I said, all right, simplify what you can. Looking at that, I say, well, I don't know how to do the whole problem right off the bat. But look at what you can simplify, which I put in red. What's the square root of 16x squared y squared, or 16x to the 4th y to the 4th? What's that?
4x squared.
So I did that, and then I go, well, wait a minute. I went from 2 radicals down to 1. Can you take the square root of that? Yeah. Same thing with the others. You took, I think it was asking you to take a square, and then you got a cube root from that. Okay? This is what I mean, and when we tell you we're throwing the kitchen sink at you, this is exactly it. This is exactly it. If you were in a Regents class, they'd sit here and we would have a pizza party if you got number 11 correct. Okay? So, oh, fabulous. We're going to give you scratch and sniff stickers, which is something that I have. Maybe if you're good. But we'll tell you, you've got to be able to take that and make that adjustment.
Did you just go back to the picture that you're
Yeah, sorry. But you've got to be willing to take that step. Now, I'll ask you this. When you're doing your homework, Do you want me to post this sheet in advance through Google Classroom or send it out through Ramon? Would that be better, or do you want to not know? Because my dilemma is if I give this to you, some of you will just work towards that. Okay. And that's why somebody said the other day, here is what your homework should look like. This was the homework that the kids in the first class gave. This is what your paper should look like. This was all of it. It took 1 page. I asked this person how long it took, and they said that it took 15 minutes last night, which I thought was sort of reasonable. Here's another person, they did their work again. But when you say, somebody said, what work do I need to show? This is a reasonable expectation for you to show. The part that we're going to hit again, and I'm not judging you in the least, I take it as a personal challenge. If you don't know your square roots yet, you need to, and we'll get you through them. But that's why when I'm saying there's this disconnect between, I think we did the survey again last class, there were some of you who were, I think this was a group that had multiple people, were the people in here with a 15-point spread between their reach grade and that? Who were those people? Okay, that's the part. I had a meeting yesterday about it because I'm so frustrated. And it's not frustrated at you. But I sit there and go, you have to have an honest conversation about what you know and where you are. And the thing that I take as a personal challenge is, just wait until you get a higher grade on a harder exam than you got last year. Just wait. If you think I take even 75s, I'll be outraged and offended if you will. Make sure, please, that your name is at the top. Yes? 62. That was another one like we did before we put the square roots up. Is that right? Okay, 62. Right away. It's a cube root. I don't know how to do this, but I do know how to do part of it. I can simplify the square root. What do you get when you simplify the square root?
8x to the third y.
Oh. And this is not right. This might be why you got it wrong. What's wrong about this as it is? Y to the 6. Why is it y to the 6? You're taking a square root. How many times does 2 go into 12? Now, this is in our radicand. Can we simplify that? And it's a cube root, and this would give me 2xy squared.
Yeah, that's like
Okay? Again, you're going to hit roadblocks. Do it now. Then when I have you for calculus, everything will be so easy. Then we'll have pizza parties. We'll watch movies every day. Not really. All right, make sure, please, that your name is at the top. Hand those up and over. You picked up when you came in. We've got to go quickly through this if we're going to get through our stuff, and you're not have to watch what the other classes did. You also picked up a function of the week sheet. Bounce over to that. Also have your note packets out and ready to go. We're going to get our function of the week done first, though. And what have we been working with so far? By the way, sorry, stop, eyes up here for a second. Sorry, I forgot to introduce somebody so far. This is not, we don't have a stalker following us. This is Miss Dixon.
Hi.
You say hello, Miss Dixon. See, Miss Dixon is going to be helping us out. See, Miss Dixon is going to school to become a math teacher, so they said, we need to find the best math teacher humanly possible. It's almost like American Idol. Right? And they said, well, can you shoulder the burden? And I said, I don't know, my kids. They're very weak. I said, I want to show her. So she's in to come and help us. She splits between myself and Miss Bailey. If you have questions, sometimes we'll try to integrate stuff maybe later on in year 2 where, and you're with us a whole year, right? Whole year. So when you're getting Christmas presents for me, remember you have to get a second. Okay, just keep that in mind. And $300 limit. Now, we're talking about, last time we were talking about linear functions. Now, and that reminds me, we're going to have to change what our graph in the back of the room looks like. Because now we're working with square root functions, so our base function is going to be y equals radical x. Hands up, please, if you can give me an ordered pair that's going to be on that. And this is week 2, by the way, and hopefully your names are unique to you. I can't put that in. Who can tell me one ordered pair? 0, 0, the origin's on there. Who can give me another one? You get it just by taking x's, plugging them in. We know that point's on there. Build what the graph looks like. This isn't a mystery. Who can give me another point that's on there? 1, 1 is on there. When I plug in a 1, I get a 1 as an output. Now, who can give me another great point that I would want to go through and plug in to this? We got 3 people. The risk taker, the processor. What? 4, what's the opportunity?
Oh, 4.
Nope, not 4, 4. 4, 2. 4, 2 is going to be on there. Who can give me another point that's going to be on our graph? Yes. 9, 3 is going to be on there. Now, these next points aren't going to fit, but they are there. So we can do this if you trend out. Not bad for freehand. Who can give me another ordered pair that's on the graph? Well, 16, 4 is on there. 25, 5 is on there. 36, 6 is on there. That's 6 for 7 is 49. So 49, 7, 64, 8, 81, 9. Look at how long it takes us to get to 9. But look at what's happening with those output values, which is your range. Who can tell me what the domain of this graph is going to be? Seriously? Wow. 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 Who can tell me what the, by the way, on your homework, on your math Excel, someone brought it in, I can't remember who, just so we make sure we cover our bases. When you input in the computer, you don't put the positive on the infinity. You do for a negative, but the computer, unless you put it, like you wouldn't put positive 1, you don't put that on the computer. When we do it in class, we list it out. Look at the range. You can tell me what the range or y values used in making this graph are going to be. 4 people. That's exactly what I was looking for. When is this graph increasing? Now be careful. It's not all the time. We can if we say something about it. But from where to where is this increasing? Who can give me the answer? 0 to positive infinity. Now I'm going to say this. Anytime you're giving an increasing, decreasing interval, you use parentheses on it. It's a notation issue. Increasing and decreasing intervals will always have parentheses on them. The reason being you don't include the 0 is, look at the point before 0. Did I have to step up in order to get there? No, it doesn't exist. 0 is where it starts, or everything after it counts. When is this function decreasing? Nope. You can't go from right to left. Never. So we can list that out as the null set, or empty set. And when is this function going to be constant? Hands up, please, if you can tell me that. Never. So maybe you could put the null set here. Another notation for it is brackets that are empty. Now, somebody said, well, isn't it always increasing? It is, but only over its domain. So you could say all real numbers in its domain if you wanted to. When is the function value greater than 0? Function f of x is the same as what, by the way? Y. When is the function value greater than 0? Hands up, please, if you can tell me that. 2 of you.
When x is greater than 0.
As an interval, what would that be? When is the f of x or y value less than 0? Hands up if you can tell me that. When is our f of x or y value less than 0? Never, because it never dips into quads 3 and 4. When is it equal to 0? Hands up, please, if you can tell me that. We got 1, 2, 3. Yeah, the origin. So we'll just list the x out. Now, there's multiple ways that you could do this. I would give it out as this. Now, to find the zeros, those are the x-axis intercept. And if you have to find them algebraically, you would go through and set the y equal to 0 and solve. So this would be 0 equals x. Oh, 0 equals radical x. What do I have to do to both sides to solve? Square both sides. Now 0 squared, if you need the calculator, go use it. You could give it out as either x equals 0 or the ordered pair 0, 0, which is the origin. But if it asks for the zeros, you have to show out the algebra. Looking at the graph is not enough. What is the maximum that this graph reaches? Hands up, please, if you can tell me. It goes, is that a value? There you go. So let's say that there's none. What about the minimums that this graph is going to reach? Hands up, please, if you can tell me. And there's some formatting, I guess we could say it different ways, yeah? Yeah, I'd say that the minimum that this graph reaches is 0. Now, here's another thing that you need to know. We'll give it out as an ordered pair, but technically when you go on to calculus, if it's asking for the minimum, it wants the y value. If it's asking where the minimum, it wants the x. I didn't say either, which is why we listed it out as an ordered pair. Now, we need to find the inverse on this. This goes back to one of the questions that was on the test that you all did terribly on. Across the board, you did terrible on this. Is everyone in here taking the test so far? Is that right? Is there anyone who hasn't? Here's the one question I wanted to show you, and this you'll all get messaged out as well. Here is, every time that we take a test, I take a random sampling of people who got a perfect page. Where was the one? This is a calculator or calculator? Here it was. Right? This was someone's, and I think this might have been someone in here, if I remember right. But in any case, looking at this, this says determine a domain for the function for which for which f of x has an inverse function. Now, what is the graph going to look like normally? That's a parabola. Is a parabola a function? Is it one-to-one? No. What do you know about functions that aren't one-to-one? They have an inverse. They don't have an inverse that's a function. Because remember, if I take the parabola and I invert it, I get a sideways parabola. Is that a function? No. So what I need to do is figure out which part of the parabola am I going to look at to make it so when I take the inverse, it's a function. Looking at this person did it out and said, all right, I can go, the lowest point it reaches is at 4, so I can go to the left of 4 or to the right of 4. But that's what you all were expected to do on that. Right? And sometimes, and again, it's not the end of the world. I'm not giving you the easy questions. Was that tough? Absolutely. I want you to be so successful, it's disgusting. But that doesn't, and you know how much of a hero if I look at, right? We all sat down to a test. Imagine what it would look like if we sat down to a test and I go, all right, love, now, how many times did you see equations like that last year? No offense, I have a 9.5-pound Chihuahua at home, some rat terrier in him. I bet you, if I took duct tape, I wouldn't do it except in school. If I took some duct tape, right, and tied a pencil to his paw, and we spent a couple of weeks doing it, I bet you I could get him to answer those questions. And the problem is, your algebra gets stuck. You don't progress algebraically. That's my frustration. And don't worry, we'll fix it. You'll sit there and be like, oh my, a toddler could do this. And by the way, you want to know a terrible day this afternoon to spend with your godson, they can hate coming over to your house for the afternoon? My godson Colin was being a little bit of a jerk. So I sat down and go, all right, you know what your punishment is? Is you're going to make me sit in a corner like my mother. Worse. I had math. We did times tables, and he couldn't get up until he knew all of his flashcard multiplication division tables. It took an hour. That's you have to grow algebraically. You get so stuck. And then we sit here and we go, again, it's not you, because are you making the questions? But I sit here and I go, you all are bright people. You're capable of looking at really complex functions like this and getting to that point. And if you're not there, that's fine. We're going to get you there. But you have to get past this 4th and 5th grade algebra. You add 2 and divide by 5. Wonderful. Now, think about the inverse of this. What do we have to do to find the inverse of this function? Switch x and y. So I list out x equals radical y. I'm going to solve this now for y by squaring both sides, so I get x squared equals y inverse, or I'd say that the inverse function would be x squared, but there's a problem with that. Look at the original. Think about what the graph you're telling me looks like. The graph of this is a parabola, right? Is this whole thing the inverse of that? We need to restrict its domain down. From where to where do we need to look at the parabola in order to find the inverse of the blue? From where to where? We've got two people that can tell me. That's not good. Remember the inverse we're reflecting over that line? From where to where do I have to look on the red graph to find the reflection over the blue? 4 of you, 5, 6, 7. We're better than this. There you go. Do you include the 0? Sure. That's what I mean, though. That's what you should have been working with. Yes?
You just say x squared is 3 equals 0.
Sure. Sure. And I think I won the test and did. Now, we don't know odd, even, or neither yet. Is this function 1 to 1? Look at the graph. Is it 1 to 1? Yes. Passes the vertical line test and the horizontal line test. What about is it onto? Hands up, please, if you can tell me that. What does it mean if a function is onto? We did it last week. 2 of you remember? You're going to get there. What? Not necessarily. No? That would be if it was a function. Onto, yes? Is every y value used in this graph? Yes or no? So it's not onto. You don't need to worry about amplitudes for, asymptotes for it yet, because we haven't talked about it yet. We don't need to worry about amplitude and period. That's for trig graphs. As x goes out to positive infinity, what are the f of x values doing? What? So where does the y values, where do they go to as we keep going out to the right-hand side? They're going to keep increasing forever, so it's positive infinity. What about what happens as we go out to the left? You said nothing. Why did you say nothing? There's no values there. The f of x doesn't exist. Now, yes, sure. Make sure. Now, for our notes today, it's going to be a little bit quick, but it's stuff that you already know. Hopefully, not already know, excuse me. Works with number sets that we already know. We're going to start off with adding and subtracting like radicals. In order for us to add or subtract like radicals, they have like index values and like radicand. So you can't subtract a cube root, it's in page 6, a cube root and a square root. They have to have like radicands and indices, which means a square root and a square root. If the number underneath them is the same, you're good. Let's take a look at question number 1. These are perfect squares. So I'll list this out in my margin because I need these values. My perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. It continues on. Somebody in the other class, somebody started listing them off really fast, and they go, he's like a calculator. It's not like a calculator. He did his homework. You don't need to be a calculator to figure that out. Now I look at these two. Root 27, they're like indices, meaning they're both square roots. They're not like radicals yet. What perfect square goes into 27? Hands up, please, when you can tell me. These are things that need to be automatic. These are not things where we're going, I need a month to figure this out. You've got to use the calculator to go to it, but you've got to be able to get to it. 9 times what? So the beginning, we'll list this out. We're transitioning away from using this. Minus 3 times the square root of, what's the biggest perfect square that goes into 12? 1, 2 of you. Oh, come on. Come on. What? 4 times what?
3.
Now, I'm going to go through and simplify. This gets crossed out here. Root 9 is 3. Root 4 is 2. So this is going to be 3 root 3 minus, now this is going to be a root 3 as well. Who can tell me what the coefficient in front is going to be? Give it a guess. What do you want to say? Not 2. Not 2. It's going to be a 6. Why did you say 6 and not 5? It's 3 times that 2 that's there. Do we have like radicals? So now we just add or subtract my coefficients. This would be negative 3 root 3. Maybe this is the one. Yeah, this is one where they're going, so use a calculator. Do your work. You become your own calculator. Take a look at this. I need to know my perfect cubes. Hands up, please, if you can tell me some of our perfect cubes. One person. Oh, if you don't know, it's because your fingers are too busy typing on the calculator. I need to know my perfect cubes. We got 2 of you. 3. What? No. No. 8.
27.
27.
64.
343, and so on. But we don't need to go past that. You've got to know these numbers. It's 2 to the third, 3 to the third, 4 to the third. If you need to use the calculator, then use it. Get it right. This is 5 times the cube root of 16 isn't a perfect cube. It's a perfect square, but who cares? How do I want to break up the 16? 8 and 2, so let's break it down into an 8 and a 2. Over here, I've now got plus 2 times the cube root of 250 isn't a perfect cube, but there's a perfect cube factor. Who can tell me how you want to break that down? 2 of us. Come on. What? Times. And then the last one, we can't do anything with. Cube root of 8 is 2. Cube root of 125 is 5. This means we multiply, and I'd have 10 cube roots of 2 plus 10 cube roots of 2 minus 3 cube roots of 2. Who can tell me what that's going to be when we combine like terms and simplify? We'll wait for 6 of you. 1, 2, 3, 4, 5. Terrific. Oh, careful. Cube roots. Thank you. Now, we've done this before, so make sure you get it down. You can split apart multiplication. If there's a product in the radicand, you can separate that out into 2 radicals. If there's a quotient in the radicand, you can split that up too. I think if I remember correctly, we did an example the other day where it started off with root x over 2 and we made it root x over root 2. Is that right? Didn't we do an example like this last class or no? Okay, I thought we did. You can do that. That's perfectly allowed. Yeah. Yes, for any index value. Doesn't work on square roots or cube roots or fourth roots. It works on any root. That's why there's n's there. Questions on that? Now, take a look at the first one up for number 3. You multiply your coefficients, multiply your radicands, simplify what's left. Looking at this, Nick, what would you have if you multiplied the coefficients together? So I have 20, and now I've got a square root. And what do I get when I multiply the radicands together? Marissa T?
12x squared y squared.
I should be so happy when I see this. Ecstatic. Because this is going to be easy. 12 isn't a perfect square, but how do I want to break it down? 4 4 and 3, so this would be 20. Those of you that need to show the step, 4 times 3 and x squared, y squared. What can we take the square root of that's here? The 4 is a 2, the x squared is an x, the y squared is a y. So what am I going to have as my new final coefficient in front? Kirsten, let us know what you get when you get it.
40x.
Keep going.
And then 30.
Feel sorry for that 3. Next one up for number 4. Looking at what's there. Sam, what do you get when you multiply your coefficients together? And then I've got the cube root of, what is in or under that cube root? Sean K. Yeah. All right, part of this I'm happy to see. And actually 30 I'm kind of glad to see. Do any perfect cubes go into 30? All right, I thought I studied for a second there.
Yeah.
Do any perfect cubes? You want that. You don't want to have to do more simple. So this is -2. This is a cube root here. I will break one thing down. This is 30. This would be x to the 6 times x and y to the 3rd. Why do I need to break it up that way? Because 3 goes into 7 with the remainder of 1. This is going to be an x cubed here, and this is a y here. So this would be -2 x cubed y, and then the cube root of 30x. Questions on that? Now we can handle the division. Let's handle the division. Looking at what's there to start, I see this and I go, God, that's awkward. So let's put it all under 1. This would be 56 x to the 4th, x to the 5th, y to the 5th, get it all under 1. We can bring it out if we need to. Does that simplify down? Look at your radicand. It absolutely does. Kayla, what are you left with in the radicand position when you simplify this down?
8 x to
Which side has more x's?
the
Nope. Which side has more x's? Numerator or denominator? By how many?
4.
Which side has more y's? By how many? Now, this is the part where we're going to actually go right to the final answer, because you're smart enough to. Hands up, please, when you can tell me the biggest perfect square that goes into 8. 4 times what? So you have a 2 out front and a 2 left underneath, because you took the square root of the number she just gave me. What else is going to be out front? Hands up, please, if you can tell me that. You can jump to that conclusion. Yeah. This is more of the same. We need to get a lot done, so let's bounce over, please, to number 7. Looking at number 7, I see something right away that I'm going to want to deal with. So I look at what's there, and looking at what's here, what is 15 over 3 the same as? 5. If I list it out as a fraction, it's 5 over 1. By the way, another thing that you all say that I guess I'm going to have to take a trip over to Spry to correct. Nothing ever cancels. Like if something cancels, you're implying it goes away, and if it goes away, what's its value? 0. But if something reduces, like 7 over 7, what's 7 over 7 going to reduce to? 1. So did it cancel or did it reduce? Which one? Thank you. Now, looking at what's here, this is a 5 out front. I need to simplify my radicand. So I've got 5. Who can tell me what's in the numerator of the radicand and the denominator? Simplify the expression that's there. Really? Wow. Wow. Go ahead.
Is it 5x to the 4th? And then y. Oh, over y. That's good.
Now I start looking at a bunch of stuff that I can go through and take the square root of. Marissa D, what's there that you can take the square root of? Good, and what's the square root of that going to be? Terrific. This goes to an x squared, and there's something else that you can take the square root of that's there. Corey, what else can you take the square root of? And what's the square root of that? Now, I need to be careful, because now I'm going to bring all this out front, and we're going to have some of us, we're going to miss this next step. By the way, what's 5 as a fraction? 5 over 1. Okay, who can tell me what they think our coefficient's going to be when I bring all of those squares out to where they need to be and make them our coefficient? We only got 1, 2 of you, 3? What do you want to say? Close. He said 5 over y, and you are so close. You forgot the easiest part, though. What? No? It's not yx squared. The x squared's in the numerator. Why is the y in the denominator? Because technically, this is 1 over y. Look at its position. Questions on that one? This next piece, again, they don't do you any favors when they start showing you this back problem. This magic rectangle of fun multiplication garbage that you do. Now, we're going to rectify it. I'm going to say this, view it as double distributing or foiling, because it's going to make everything so much easier instead of having all these disjointed pieces. There's two binomials multiplied together. Let's multiply our first terms together. And looking at what's there, AJ, what would you have if you multiply the first terms together in these two binomials? Now I need to do the outside terms. And Riley, what are you going to get when you multiply the outside terms together? Now we're going to have to multiply the inside terms together. And Royce, what am I going to have when I multiply the inside terms together? Positive 2 roots of 5. Now I'm going to multiply my last terms together. And Philip, what's that going to give you? Careful. Negative 5. Pay attention to the sign. You went to 5, though. Why did you go to it so quick?
Because 5 is 25 and 25 is 5.
Terrific. Let's put our like terms together. What do I get if I put my like terms together?
6 minus 1 is
Not 6. These are like terms here. Questions on that? Take a look at number 10. When we go through and do number 10, first, outer, inner, last. By the way, notice, how are these related to each other? Look at the two binomials. They look pretty darn close, except for one thing. What changed? The sign in between them. Let's FOIL this. First terms multiplied together. Amanda P., what would you get? What about my outside terms? Sean L.? Negative 5 root 3. Sorry, that should be a positive. What about the inside terms? That would give you out A. What do you get when you multiply the inside terms?
Negative 5.
Sorry. And what about when I multiply my last terms? Hands up, please, if you can tell me what that's going to give you. Multiply the last two terms. What are you going to get? 2. Can you give us our final now? That's it. What went away?
the positive 5 rather than the negative 5.
There you go. There was a reduction there. They reduced out. That's called having a conjugate, and this is something that you need to make sure that you know. If you have a conjugate, that means there are two binomials where the only thing that's different between them is the sign between the two terms. So it could look like this. Negative 3 plus root 2 and negative 3 minus root 2. What changed between those two things? Sign. Left and right half are the same. What changes is the sign in the middle. When you do that, you don't get the radical left over anymore if it's a binomial with a root in it. Now, take a look here. We can do this one quickly. What would we get if we did out number 11? Actually, let's do this, because we need to make sure we get to bounce over, please, to number 13. Because we're going to be doing the same thing in number 13 as part of the problem. Looking at what's there, why couldn't I leave that as a final answer? Who can tell me? So what we need to do is, remember how before we talked about an ugly one that's going to get the radical to go away? You now know the ugly one that's going to get the radical away. It's going to be the conjugate of the denominator. So looking at what's there, can anybody tell me what they think the conjugate of our denominator would be? We've got 1, 2 people. What do you think the conjugate of the denominator in this case would be? Seriously, 2 people? 3, 4? And it's got to be an ugly one, so 2 minus root 3 and 2 minus root 3. Now, in the numerator, I would distribute that out. Nancy, what are you going to have in the numerator when you multiply out the 5? Now, down below, we've got 2 binomials multiplied together, so I always ask that you do this messy work over on the side. We've got 2 plus root 3 times 2 minus root 3. If I were to do this out, you're going to have to FOIL it, so we do it to the side. We don't want it to muddy up the question. Looking at what's there, first terms multiplied together, Grace, what are they going to give you? 4. What are the outside terms going to give you when you multiply those together? What about the inside terms? What about the last terms? Negative radical 9, which is just a 3. So we get to this point. What's next? Simplify what's there. Yeah. These reduce out, and you're left with 4 minus 3, which is 1. Now, technically, I wouldn't expect somebody in this course to leave that as a final. Technically, you'd leave that as your final. Questions on that? Let's bounce over them, please. What if I have this? 1 plus root 5 over 1 minus root 5. The only radical that's a problem is the one in the denominator, so we need to get rid of it. What do I need to do to get rid of the radical in the denominator? Yeah? So let's do 1 plus root 5 over 1 plus root 5. Now, I'm going to say this. You 2 rows over here are going to multiply the 2 binomials in the numerator. You 2 rows over here are going to FOIL out and tell me what you get when you multiply in the denominator. So we're only doing half of it so we can make sure that we finish. You 2 rows, write them out. 1 plus root 5 times 1 plus root 5. First order and last, raise your hand when you've got it. You 2 rows over here are going to do 1 minus root 5 times 1 plus root 5. First outer and last, and then get an answer for that. Hands up, please, when you have what your FOIL comes out to be. We got 1 so far, 2, 3, 4. Which one did you have? The denominator? What'd you get? Okay. Denominator comes out to be negative 4, and that's right. Who can tell me over here what we got for our numerator? 3 people? Seriously? What?
2 radical 5 is 5.
No.
6 was 2 radical 4.
What does it come out to be?
6.
I think so. 6 plus 2 roots of 5. I think this is it. Now, I would not expect you to leave that as a final answer. Is that what we got over here or not? You have to do first order and last. You should get 1 squared, which is 1. The outside's going to give you root 5, inside's root 5, then the end's going to be root 25, so that's right. Now, yes,
Bottom.
because you'd have 1, the outside and inside's reduced out, you've got minus root 25. Now, when we get to here, why wouldn't you give that as your final? What do they all share as a coefficient? 2. So you can give this as 3 plus root 5 over negative 2. But who likes a negative in the denominator? So this would be, let's bring it up to the numerator, negative of 3 plus root 5 over a positive 2. All of those are acceptable, alternate, but equivalent answers. Your homework is through that packet. Make sure you get it done for next time that we meet. Have a terrific rest of your day. I'll miss you terribly. We don't see each other tomorrow. Don't cry. Yes. Are you in the second section? I'm not. When did you? I have to double check. I don't know when you all took it. I'm not 100%. Thank you. So if I don't know if I have it. There should be columns in there. If not, it'll be in by the next day. Yeah. Yeah.
How is that 2 negative 2 is 1 minus 3?
Well, you're right, but it goes down. I say which side has more y's? Which the denominator does 5, 2. So you're right. Y to the negative second is the same as 1 over y squared. Okay?
And then in the homework, when you said how many times does 3 go into 12?
Hang on 1 second. You're talking about the homework? Do you remember which question?
62.
62 over here, the 64 one? This was the one that you asked about, right?
How many 3s go into 12?
Hang on 1 second. Let me make this big. It didn't take it. Let's just see. So you're here. Where did I go? Here. Paste. Make it nice. Make it nice and stupid thing. Okay. So this is the cube root of a square root of that amount. Simplify the square root. What's the square root of 64?
8.
What's the square root of y to the 12th going to be?
Are we doing like a square root or
When it's a square root of a variable, you're seeing how many times the index goes into the...
Isn't it 4?
No, how many... No. That's for a cube root. How many times does... This is a square root here, right? So how many times does 2 go into 64? Or sorry, how many times does 2 go into these powers?
3 and then
3 and 6. And then you take that new answer
so
and
it's
take the
not
cube
cubed
root.
anymore?
Then you take the cube root.
Okay.
Because they're not both cube roots.
Okay, I was like, 3 does not go into...
No, and you're right. You were thinking that they're both cube roots,
Yeah,
though.
okay.
But that should be disconnect because the cube root of 64, though, isn't 8.
The cube root. Oh, yeah.
Because you took the square root for the first halves of it and not the last third.
Right.
Okay? So you'll get there. Don't worry. Don't worry.